Today we are going to discuss quantization and training of neural networks for efficient integer arithmetic-only inference. This paper tackles a critical issue in deep learning, making neural networks efficient for mobile devices. The problem is that modern deep learning models rely heavily on floating-point arithmetic, which is not optimized for power-efficient hardware like mobile CPUs. The authors introduce a quantization method that allows inference to be done using integer-only arithmetic, significantly improving efficiency without losing much accuracy. So, how does quantization work? In simple words, it works by mapping 32-bit floating-point numbers to 8-bit integers using a scale factor and zero point. This allows all computations, like convolution and matrix multiplication, to be performed with integer math instead of floating point. During training, the model still operates in floating point, but simulated quantization layers mimic the effects of integer constraints. This ensures that when deployed, the model is already optimized for quantized computations, reducing accuracy loss. The key issue this paper solves is that previous quantization methods either suffered from significant accuracy drops or weren't optimized for real hardware. Binary and ternary networks used extreme quantization but lost too much precision. Other methods quantized only weights but left activations as floating point, limiting efficiency gains. This paper presents a fully optimized pipeline that delivers both speed and accuracy. The biggest advantage is efficiency. On Qualcomm's Snapdragon processors, an 8-bit quantized mobile net achieves nearly 10% higher accuracy at the same real-time speed, 30 FPS, compared to its floating-point counterpart. The reason is simple. Integer operations are much faster and consume less power than floating-point calculations on mobile hardware. Let's break it down with an example. Suppose a neural network has weights like 0.45, -1.23, and 2.67. Instead of storing them as floating-point numbers, we scale and map them to integers, say 115, -210, and 207, 342. The same is done for activations. Instead of performing costly floating-point multiplications, we use integer operations, then scale the result back to get the final output. This drastically reduces computational overhead, while preserving accuracy. Is this method perfect? Not entirely. Quantization introduces small precision errors, and certain models, especially those with very small weight values, can suffer from accuracy degradation. The paper addresses this by carefully fine-tuning quantization parameters and allowing some layers, like biases, to remain in higher precision, 32-bit integers, to minimize errors. In summary, this paper provides a robust solution for running deep learning models efficiently on mobile devices. By using integer-only arithmetic, it significantly reduces computational cost while maintaining accuracy. The approach works especially well for architectures like MobileNet, which are already designed for efficiency. This breakthrough makes real-time AI applications, such as image classification and object detection, much more practical for smartphones and other low-power devices.